Good morning. Welcome to a new presentation. Now, I am going to discuss about data analysis from Nepal Demographic and Health Survey. So, first of all, I would request to download dataset from DIC's website. So, if you would like to analyze Nepal Demographic Health Survey, then obviously you have to download dataset from Nepal site. So, you have to select Nepal site, then you have to download the data set children record, that means NPKR, this data set. Since I will discuss based on STATA, so obviously you have to select this. Then download process. And if you click here, then download, the data will be download. So I have kept the data set in D drive and I made a folder ABC, small letter, and I kept the data set in this folder, this NPKR. Just I will open this data set. So first of all, I have to open data set, go to D drive, ABC folder, and there are many data set, but I will open where is this data set? NPKR, this data set. So yes, it's open. So this is the KR data set. So this is data view. So now we will calculate the nutritional indicator, stunting, wasting, and underweight. So obviously we will you work in do file. This is on kind of syntax file. So these are our syntax for opening data. Use D drive ABC. So already I have discussed how to analyze, how to open data, how to prepare a do file. So if you like to learn data analysis, the basics of data analysis, so you can watch the previous video. So I have discussed there how to open data, how to analyze data, how to manage data, etc. So today I will go to the direct data analysis. So first of all, we will open the data. So first we will calculate stunting, wasting, underweight, as well as some associate factor. But since this is the complete practice purpose, so obviously we will not use all variable. That we will use some selected variable. So there are many variable, but we will some selected variable. So the syntax is very long, so we can break down using this command. Just we have to type space /1 2 3. Similarly 1 2 3. Similarly 1 2 3. Yes, this is our complete syntax. If we keep, then this variable will be selected. Okay, run. This is run button. Okay, so selected variable. So first of all, we have to calculate the stunting, wasting, and underweight. So this variable for height for age z-score, this is weight for age, and this is weight for height. So we have to use first three variable. So if your BR means browse. So after browsing, okay, this is our data set. So this is minus 378 means 3.78. That means This is the 2 decimal place data. We have to divide it by 100. But before going to main analysis, just we can summarize this raw variable, just sum this variable, this variable, this variable. Yeah, the maximum value 999. This is not value. This is a code either missing or etc. So if we give tab hide for S, okay, this is flag. Flag means if we see the value null, yes, 999 means this is code, and this code represent flag. That means we have to remove, that we have to replace by missing. So how? Just replace this variable is equal to missing if this variable greater than 9,000. That means since this value is 9998, so if we give the command if greater than 9,000, then it will be okay. Similarly this variable, similarly this variable. Okay, so we can copy the syntax and we can, yes. So if we sum, yes, now it is okay. Now we have to divide by 100 because it's 2 decimal place data. So then has means height per z square, has means this variable 100. So this is was means 7 ones, and this is WZ, this is 2. So has, was, and WZ. Has means lever, we have to define variable level has. So how to define variable level, how to define value level? Obviously, you have to watch the previous video. Already I have create a playlist, the basic stata for beginner. So has means height for SZ score. So just copy. This is was, and this is weight, and this is WAZ, and this is WIGH weight for HEIGHT height for is okay. So if we run, sorry, we have to, yes, 3 variables were generated. So we keep the variable in the first item. So ORDER, order, has, was, WAZ. So if you order, yes. So now we have to define stunting, wasting, underweight. So first generate, so first, then stunting, is stunting is equal to 0, replace stunting is equal to 1 if has less than -2. This is the definition. Okay. And obviously we have to define the missing value. Missing if dot dot missing. So this is the mandatory. Obviously, if we generate variable, replace variable, then in the last line we have to define the missing value. This is mandatory. Okay. So now lever stunting childhood stunting. Okay. So similarly, since the all type of syntax same, so we can copy, and obviously it will be wasting, and it will be so underweight, then it will be was, and it will be underweight. Okay. Similarly, we have to define wasting. So wasting, and this WAZ. Okay. Then order wasting, underweight, and wasting. Okay. So if we give run, yes, stunting, wasting, underweight. If we give tab stunting 27%, but obviously we have to, since it's the nationally represented data, we have to adjust the weight variable. Weight. This is the sampling weight. 6 decimal place. 6 decimal place means we have to divide by 1,00060. That means we have to then SWT sampling weight command divided by 1. Then 6 times 0. So if we give run, this is sampling weight, lever SWT sampling T, sampling weight. Okay. Okay. SWT. Yes, this is sampling weight. So obviously we have to adjust weight. So this is the command. Just IW means important weight is equal to SWT. Yes, 24. So obviously this result will be not matched 100% with reports because this report based on the individual data set, and there are several types of data set. If we where is the individual member data set? Birth record, couple data set, personal data set. So we have to use personal data set. Oh, sorry. If we use this data set, if we use this data set, then the result will be matched 100% with the report. But if we use a children data set, then the result will be not matched 100%, but it will be matched approximately equal. For example, the number is 2641. On the other hand, in our analysis, the n is 2525. So if we tap wasting, underweight 18% and wasting 7%, 7.9%. So this is our syntax for calculating childhood stunting, wasting, and underweight. So now we can analyze data. For example, tab stunting with place of residence, comma, Chi. So another important variable is maternal underweight, maternal nutrition. So first of all, we need maternal body mass index. Here, this is body mass index. This is 2 decimal place that we have to divide it by 100. Then we can use this. But today we will calculate BMI using height and weight, because we know that the definition of BMI is weight in kg divided by height in meter square. These are definitions. So we use this definition. So please see that in the DSA data set, this is weight, this is a height, but obviously we have to divide by 1. So we divide by 10 because this is 1 decimal place, because it is 1 decimal place. This 1 decimal place. So we have to divide by only 10. So now we can use tab. Okay, there are large value. Null means null level. Okay, sorry, we have to missing, we have to replace missing this value. So replace if also replace this value if this value greater than 90. Replace this value is in missing if greater than missing. So that two value already, two values. Okay. Then we have to create maternal height. Then W is equal to divided by 10. This is weight and this is height. This is height. Okay. This is weight. This is height. So obviously we can define lever W maternal body weight in kg. Lever is maternal ACI height in centimeter, because in the data set the unit is centimeter. But if we see the definition, this is height meter square. So we have to BMI is equal to weight divided by height square, but height the unit is centimeter, we have to convert meter. For this reason we have to divide by 100. Okay, if we run, okay, sorry, yes, now BMI has been generated. So we can generate, yes, this is BMI. Okay, this is BMI. Yes, it is BMI. So lever BMI body mass index. Nepal. So we can two variable, or we can prepare a variable, the even underweight if BMI less than 18.5, normal if BMI 18.5 to 2.55, overweight, over GH overweight, if BMI 25 to plus, overweight or obesity, overweight or obese. So we can create a syntax into file. So then BMI cat is equal to 1 if BMI less than 18.5, replace BMI cat to if BMI greater or equal 18.5 and BMI less than 25. 25 mean 24.99. Replace, just will copy, replace, so to 3, it will be 25 and it will be dot. Dot means the last z value. And the last value, obviously this is a mandatory, already I have mentioned. If BMI, okay. So lever BMI category, BMI category, lady, replace 1 means underweight, 2 means normal, 3 means overweight or obese. Then level 2 times the variable. So this is how to define the variable level and value level. So if you don't understand, then please see my previous video on variable. So we can define value level here also. The stunting 1 0 replace stunted not stunted. Level so we can use same command for underweight. So here underweight, 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 underweight. Same command for same command for same command for wasting. Sorry, wasting. Wasting, 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 wasted, wasted. Okay. So now order this variable. So now we can run the all variable. Run. Okay, this is sampling weight, height for the age score, weight for age, weight for height, stunting, wasting, stunting, underweight, wasting, body mass index mother, body mass index cat. So tab, yes. So if we like to stunting versus maternal body mass. Okay. So if we'd like to estimate the associated factor of stunting, then logistic stunting, then the main variable is maternal BMI cat. Since this is category variable, so we have to type I dot. Overweight. So the category of BMI cat is 1, 2, 3. If we take reference normal, then IB2. 2 means normal. So if we press yes, that means 1.3 means if mother will be underweight, then chance of having stunting was 1.3 times higher. So if we give another variable place of residence, this is also category variable for this region. We have type I dot. Another variable is wealth index. Wealth index. IB5 dots because 5 means recessed. So we like to define recessed as reference. So yes, the poorest, the chance of having stunting among poorest people was 2.8 times higher compared to the recessed. So we can use another variable is education I dot. So we can use child sex I dot. So we can just is the example. So we can use logistic regression to find out the associate factor. So this is standing. We can use underweight. We can use wasting. This is just example variable. So based on our research question, we can use the other variable as well. Yeah, this is factor associated with wasting. This is for underweight, and this is for stunting. So now, question, for example, here there are 5 category of oil things: the poorest, poorer, middle, richer. So the here recessed is the reference. If we like to define middle is the reference variable, then obviously we have to IB 3 because the code of middle is 3. So we can, like this, we can change our reference category. So Using this procedure, we can analyze the demography and health survey data. Just today, I have discussed the example, some variable, we can use the previous another analysis. So I would request if you would like to know another analysis, then please give the comment in the comment box. Then I will prepare or will make the video based on your question. Just I have discussed with how to create a nutrition indicator, maternal and child. And this is my syntax. After pausing the video, you can use this syntax for creating this indicator. So now I'm stopping here. Thank you for watching this video.